Okay. At the same time?
Saturday and Sunday the same time, 9 o'clock. Only on Monday
Okay.
2 to 3 noon.
Okay. So let's start it.
Yeah, okay.
Now we are going to start a variance and then we'll do standard deviation because standard deviation just a square root of variance.
Okay.
So let's start variance. Variance. First of all, we'll do for raw data and then discrete data and after that for group data. We'll do one by one. So first of all, let us do for raw data. In raw data, we have only values as I told you. In discrete and group, in discrete we have frequency also, and in group we have class interval along with frequency. So the formula to find variance, and variance usually denoted by, in some book they'll use this symbol as a square or they use this sigma square. You know, this is for sample. We usually find for sample, okay? Because
Okay.
in population we have large data. This is for sample and this is for population. Population means we have large data. So we usually find for sample. But in some book they give this symbol. So don't be confused. Sigma sigma square is variance and while sigma is standard deviation. And we usually
Yeah.
use the symbol small s, okay?
Okay.
So formula to find variance is, we are finding for sample, so that is why we are using this as a square. And that is equal to, for raw data, summation x minus x bar square over n minus 1. Okay. And standard deviation, the square root of that. Standard deviation is denoted by s only and then take square root of this. Summation x minus x bar square over n minus 1. Okay, these are the formulas of variance and standard deviation. Okay, and we can find any one of them, then find another one. Like if you find variance and taking square root, then you can find standard deviation also. Okay,
Okay, ma'am.
got it? Yeah. So let us do an example to understand this well. Let us take data 10, 20, 30, 40, 50. So now first of all to find variance we need this x bar, that is mean. Okay. So let us find first of all x bar. So x bar is just add all values because mean is sum of all values divided by number of all values. So we have these five values and number of values are five. So just now add them. This is 150 by 5 and so we have x bar is equal to 30. And now we need to find standard deviation. So we need to construct a table for that. So let us construct a table. We have x, and in next column, x minus x bar we need to find, and after that we need to find its square, x minus x bar square. Why? For this formula, because we need it, x minus x bar square. That is why. So let us find. So x we have 10, 20, 30, 40, 50. And now x bar is 30. So just 10 minus 30, we have minus 20. And 20 minus 30, we have minus 10. And 30 minus 30, we have 0. And 40 minus 30, we have 10. And 50 minus 30, we have 20. And now let us find its square of each value. So minus 20 square, we have 400. Minus 10 square, we have 100. 0, 10 square again 100. And 20 square, we have 400. And now we need to add these all values to find x minus x bar square. So we have here 1000. You know, sum of all these values, we have 1000. Got it? And and number of values, we have 5. So find variance. Variance as is equal to the summation x minus x bar square over n minus 1. So now let us put the values. So variance as a square, sorry, as a square, not as a square is equal to summation x minus x bar whole square is 1000. Now n is 5 minus 1. So 1000 divided by 4, and we have 250. Got it? Hello?
Yes,
Are you getting
yes,
me? Okay.
I,
Okay. So now let us find standard. This is variance, and now let us find standard deviations.
okay,
Standard deviation is as, so let us find means as by taking square root of as square. Okay. And then we can take this 5 root to 10. Okay. So this is required standard deviation for the given data and variance also.
okay, ma'am.
Okay. So let us do now variance for discrete data, then we'll do for group data. Okay.
Okay, ma'am.
For discrete data. For discrete data, we have a corresponding frequency also. So formula is the same, just we multiply corresponding frequency also. So variance S square is equal to summation, just multiply f with x minus x bar whole square, and we'll take here n minus 1 also, and where this capital N is equal to sum of frequency. Okay, and similarly standard deviation, S is equal to square root of summation f into x minus x bar whole square over n minus 1. Okay, just multiply f. Okay, as we have f in discrete data, nothing else is changed. Got it?
Yes, ma'am.
Okay, so now let's do one example related to these formulas.
Okay.
So we have f and f2, 4, 6, 8, 10, 12, 16, 18, and 20 we have. And we have 5, 3, 2, 1, 6, and 7, 10, 12, and 4. And we need to find variance and standard deviation for the given data. So first of all, we need a x bar also. So first of all, we need to find x bar mean. So we have x and f. To find x bar, we need f into x also, because mean x bar is equal to summation fx over summation f. We have done this formula already, so we need a column of this also. Now next, we'll find x minus x bar, then x minus x bar take whole square also, then just multiply f with x minus x bar square. Okay, so let us write values. That is 2, 4, 6, 8, 10, 12, 14, 16, 18, and we have one more value. Okay, 20. In corresponding frequency, they have 5, 3, 2, 1, 6, 7. Okay, 10, 12, 5, 3, 2, 1, 6, 7. Okay, 12 and 4. So f into x, we have 10 here, 12, again 12, 6, 8, 60, 84, 140, and 16. Okay, I think one frequency is missing. Okay, let me check. 10, 12, 14, 16, 18, 20. So 5, 2, and 5, 3, 2, 1, 6, 7, 10, 12, and 4. So 2, 4, 6, 8, 12. Okay, one value is missing here. Sorry, that is why. 14, 16, 18, and 20, and that is 1. So 140, then 16 into 12, we have 192, and 40 into 4, we have 80. Oh, okay. No, 80 into 4, sorry. We have 72. Are you getting this?
Yes, ma'am, I'm getting it.
Okay. And 20 into 1, we have 20 only. So now let us find this summation fx and also summation f. By using calculator, we can do. So sum of frequency 5 plus 3 plus 2 plus 1 plus 6 plus 7 plus 10 plus 12 plus 4 plus 1. 5, 3, 1, 6, 7. Okay, 10, 12, 4, 1. And we have here 51. Now fx 10 plus 12 plus again 12 plus 8 plus 60 plus 84 plus 140, 140 plus 192 plus 72 plus 20, 610. So we need to just divide 610 by 51. Okay, and it is we'll get 9.9 11.96. Actually, I have taken this random example, okay? That is why we have such values. So let us divide 610 by 51. So we'll have here 11.96. Now we need to subtract this 11.96 from each value of x. So 2 minus 11.96. Okay, we have here. Shall I write here directly?
Yes, yes, ma'am. You can.
Okay. And now let us subtract from 4 minus 11.96. So we have minus 7.96, and again from 6 we are subtracting. So we minus
11.90.
5.96. Okay, then 8 minus 11.96. So we have minus 3.96. Okay, and then minus 1.96, and this 12 minus 11.96, then we have 0.04. And then from 14 we have 2.04. Okay, again from 16, when we subtract this, when we have 4.04, and from 18 6.04, and from 20 8.04. Now we need to find its square of each. So that is 9.96 into 9.96. We'll have here 99.20, and again this multiplies 7.96 into 7.96, 63.36. 5.96 into 5.96, 35.52, and 3.96 into 3.96, we have 15.68, and 1.96 into 1.96, we have 3.82. 4, and again just multiply 0.04 into 0.04. So we have 0.0016. 2.04 into 2.04, we have 4.1616. Again, let us multiply 4.04 into 4.04. Then we have 16.3216. Again, we are multiplying 6.04 into 6.04. Then we have 36.4816. And just multiply, sorry, just leave the last two digits. Means just take up to two places of decimal, no need to write because it has only this value. That is why we are taking here. And just next just 8.04 into 8.04, because if they they say I mean they have mentioned here in question take up to four places of decimal, only then can take up to four places of decimal, otherwise we can take up to two only.
Okay.
64.64. Now we need to multiply to each value corresponding frequency now. So let's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have 10 values. Yes. So we have done for all. Now let us multiply this corresponding frequency to these values. So 99.20 is multiplied with 10. So obviously we'll get 992. Then 63.36 multiplied with 12. So we have 6, sorry, 760.32. Again, 35.5 or 5 to just multiply with again 12. Then we have 5, sorry, 426.24. And then 15.68 is multiply with 8. So we have 125.44. And now 3.84 multiply with 60. Oh shoot. Oh sorry.
Oh,
By mistake
yeah.
I have done this. Sorry, I forgot. Okay, my mistake. We need to multiply just f. We have these values. Sorry. Okay. So just multiply
5 into
99.20 with 5. Yep.
5.
This is 496. Then 63.36 multiply with 3. So we have 190.08, and then 35.52 into 2. We have 71.04 and 15.68 in into 1 only. So we have 15.68 only. Now let's multiply 3.84 with 6. So we have 23.04. Now 0.0016 just multiply with 7. So we have 0 0.01 only. And 4.16 just multiply with 10. So we have 41.6. And next, okay, and next to our this 16.32 multiply with 12, we have 195.84, and then 36.48 just multiply with 4, we have 145.92, and then 64.64, just multiply with 1, so we have value itself. Now we need to add these all values. Okay, so 496 plus 190.08 plus 71.04 plus 15.68 plus 23.04 plus 0.01 plus 41.6 plus 195.84 plus 145.92 plus 64.64. So 190, 496, 190.08, 171.04, 51.68, 23.04 and 0.01, 41.06 and 195.84, 145.92 and 64.64. Okay, and we have sum this summation f into x minus x bar square is equal to 1243.85 we have. Okay, we have this value.
Yeah.
So we need to find now variance. So to find variance, just use this formula. Okay,
Okay.
so we have here 10 values. So obviously when we put n minus 1, so sorry, 10 minus 1, obviously we'll get this. Obviously, here n, sorry, n we are using sum of frequency. Okay, this capital N is sum of frequency. So let us find the summation f also. So
Yeah.
summation f is 51, and so variance. Okay, let us find on next page. Variance s square is equal to summation f into x minus x bar whole square over n minus 1. And here n is equal to summation f, and that is equal to 51. So now put the values. So we have summation f into x minus x bar is 1243.85, and n is 51 minus 1. So we have 50 here. So just divide this value by 50. So we have result 24.877. So we can round off 24.88 as. Okay. So this is the variance.
Yeah.
And we can find standard deviation. In short, we write this as D. Okay. For standard deviation, they use this symbol standard
Okay.
as D, and symbol is S only. That is square root of variance just. And just take square root of 24.88, just find it. 24.88. So we have standard deviation of 4.98. This is required variance in standard deviation. So you got it?
Got it, ma'am.
Okay. So now shall we do for group data?
Yeah, sure.
Okay. So for group data, formula is same, but in group data, same as discrete data. Okay, formula is same, but in group data, we need to find value of x by using a class interval. Okay,
Okay.
so yeah, for group data. So variance is same as square is equal to summation f into x minus x bar square over n minus 1, where n is equal to summation f, and standard deviation S is equal to square root of summation f into x minus x bar whole square over n minus 1. So let us do one example. You got this formula because formula is same. So now let us understand this for group data by
Got it,
using
got it.
example. Yes.
Yeah.
CI, class interval, and we have frequency. 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. And we have corresponding frequency 5, 3, 4, 2, 1. And we need to find its variance and standard deviation. So to find variance and standard deviation, we need first mean, okay, x bar. So let us find first of all. And to find mean, we need a x by using this class interval. So let us find. So Ci in F. Then let us find mid values. And it is denoted by x. And then we'll find x minus x bar, and after that we'll find x minus x bar whole square, and then we'll find f into x minus x bar whole square. Okay, so let us take class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40. Okay, we need gap also to find f. Sorry, 0 to 10 we need some gap, and 10 to 20, 20 to 30, and 30 to 40, 40 to 50. Corresponding f is 5, 3, 4, 2, 1. And mid values, just add these both values. 0 plus 10 divided by 2, we have 5. Similarly, add these both 10 plus 20 divided by 2, we have 15. And 20 plus 30 divided by 2, we have 25. And 30 plus 40 divided by 2, we have 35. And 40 plus 50 divided by 2, we have 45. So now we have values of x. Now let us find x minus x bar. So to find, we need f into x also. Yes, to find uh, like mean. Okay, so I'm just because we don't have space, so I'm just writing here. Okay, even we need to write on right side, but we don't have space. That is why I'm using here. So will you understand that?
Yes, ma'am.
Okay, so mm, let us. I'll write a little bit small. So we have 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50 we have. And we have corresponding f here, and then we'll find f into x here. Here we need to find summation f also, and corresponding frequency f is 5, 3, 4, 2, 1, and f into x. We have x 5 and f is also 5. We have 25 and 45, 15 into 3, and we have 100, 25 into 4, and 70 and 45. You got it?
Yes, ma'am.
Okay. So now let us find the sum 25 plus 45 plus 100 plus 70 plus 45. So 25 plus 45 plus 100 plus 70 plus 45. So we have two summation f into x. We have 285. Okay. So now let us find x minus x bar. So first of all, we need to find here x bar mean that is summation f x over summation f. So this is 285 divided by um, 15.
Yeah.
15. So x bar uh, we have 19. Okay. So now subtract x bar from each value of x. So
Mm-hmm.
5 minus 19 we have minus 14, and 15 minus 19 we have minus 4, and 25 minus 19 we have 6, and 35 minus 19 we have like 16, and 45 minus 19 we have 26. So x minus x bar let us find. So this is 196, 16, 36, and 256. It's 256 and 26 into 26. We have 676. And now let us find corresponding means values of frequency. So 196 into 5.
Five.
We have 975, and next is 16 into 3. Okay, 48, and 36 into 4, 144, and 256 into 2. 256 into 2. We have 512, and 676 into 1. Okay, only one. So we have same values. Now we need to add these all values. So 975 plus 48 plus 144 plus 512 and plus 676. So we have this summation f into x minus x bar whole square is, or we have 2355. We have this value. Okay, so now let us find variance and standard deviation. So variance as a square is equal to summation. We have this summation f into x minus x bar whole square. We have 2355, and n minus 1 n is n. We have here 15. See, summation f is 15. So we'll take 15 minus 1. So 2355 is divided by 14. So we have 168.21 variance. And let us find standard deviation. S is equal to summation S square, which is S square, variance. So we are using this value.
Mm.
So take square root of 168.21. So we have 12.96. So you got it? How can we find variance and standard deviation for each
Yes,
data? Yeah, for all
got
data,
it, ma'am.
this data. Yes. Now let us see the next topic which we have. Just a second. Okay, so let us know first probability. Okay, because we have done measures of central and spread. Okay, so let us know the probability. Then we'll do. Okay, first of all, let us understand continuous and discrete random variable. Okay, then we'll do about mutually exclusive and non-exclusive event. Then dependent and independent. Like we here we are going to start like terms related to probability and probability distributions. Okay, so first of all, let us understand discrete random variable. Then we'll do continuous random variable. Okay, what it mean? Let us understand this. So, like first of all, let us understand random variable. Okay, what it mean? Like if we toss a coin, then we have outcomes. Either we can get head or tail. Okay. Either we
Okay,
can
ma'am.
get when we toss a coin, then obviously we'll have all possible outcomes. Either we can get head or tail. And if we toss two coins together, second condition, we toss two coins together, then outcomes, all possible outcomes we have. Like we can get head on both, either tail on both, head on first, and then second on second we have tail, or tail on first, second we have head. All possible outcomes we have these. Are you getting this point? Are you getting? Similarly, if we toss three coins together, if are you getting this thing? This step you got this or not?
Yes, ma'am. Yes, yes. I'm following.
Okay. Okay. So let us do next. If we toss three coins together, then all possible outcomes we have. See, we can get head on three. We can get either tail on all three coins. We can get head on first two and tail on the last. Okay, head on first, tail on second, head on last, and tail on first, head on second, and head on third. And we can get head on first and tail on both last, and tail on first, head on second, and tail on last. And we can get tail on first two, then last we can get head. So these are all possible outcomes. Okay, these are all
Yeah.
possible conditions in which we can get head or tail. Okay,
Mm.
so if we find random variable, like we are taking let x be
Yes.
a random variable, and let x represent number of heads. Number of heads. So all possible. So we are doing for this experiment. Okay. So all possible value of x we can see here. See, for no head, x is equal to 0. Okay. For no head. Okay. Here we don't have any head. Okay. So we are taking number of head 0. For one head. Okay. For one head, how many? Oh, like for one head, and for two heads, we have all possible outcomes. For one head, and for two heads, and for three heads. Outcomes, number of outcomes. Sorry, for no head we have only one outcome. Okay. For one head we have three. For one head we have three outcomes. For two heads we also have three outcomes, and for three heads we have only one outcome. Okay. So when we choose according to this experiment or randomly, okay, so this variable x is a variable, and we are choosing its value from random experiment, okay, then it is said to be a random variable, because its value is not fixed. It depends on experiment, means that how many coins we are taking together to toss, or how many times a coin toss. Okay, so obviously value of x depend on that. Are you getting this point? Are you getting? Hello?
Yes, ma'am.
Hello?
Can you
Okay,
hear
all
me,
right.
ma'am?
Yes, now I can hear you.
Okay.
So now you got it, what it mean by a random variable, or how
Yeah.
can we choose the value of x? Okay, all right. So see, if we have fixed value like 0, 1, 2, 3, and all another also, so we have means a certain value. So we can say this is discrete random variable. If like we have values, like we have value of x like 0 to 10, 10 to 20, okay, then we can say means here we are talking about number of hats. So here if we take 0 to 1 hat, 1 to 2 hat, 2 to 3 hats, then we can say this is continuous random variable. Okay, and we
Yeah.
have individual value, so then we say this is random variable. Oh, this is a discrete random variable. Okay, are you getting this point?
Yes, ma'am. Yes, ma'am.
Okay. So let us introduce probability. Okay.
Okay.
Okay. We need to take another whiteboard because we have completed 12 pages of that. So I'm going to